All right, I think we'll begin. So welcome everyone. Thank you for joining us today for this official OHA webinar titled A Brief Introduction to Artificial Intelligence and Oral History. My name is Stephen Sielaff. I wanted to just draw your attention briefly to our code of conduct that's on the screen right now with the QR codes. We have both our code of conduct and our harassment policies on the screen. Hopefully this will be a very informative and friendly session today. But if you're just curious in either of those, please visit the website, and as well as many other wonderful things that are on the OHA website, oralhistory.org. So to get us started today, we are going to be presenting to you a short introduction into the world of artificial intelligence. This presentation, sponsored by the Oral History Association, is being conducted by myself. I am Stephen Sielaff, Senior Editor and Collection Manager of the Baylor University Institute for Oral History, which also houses the Oral History Association, for which I am the current Associate Director. Joining me today is my co-presenter, James Fowler, who is CTO of the Association for Diplomatic Studies and Training, or ADST for short. Also joining us today is my Artificial Intelligence and Oral History Symposium co-chair, Sarah Milligan, who will be monitoring the chat and also monitoring the question and answer platform for our webinar today. This is a good time to let you know that we will have a robust question and answer section at the end of our presentation today. So if you have a question that pops up as either James or I are detailing all of these intricate details of the oral history world and the artificial intelligence world and how they intersect, please either hold on to them or drop them into the Q&A option down below. You can also make an anonymous question if you so choose through that window. Also joining us today is our program associate for the Oral History Association, Haley Rowe, who's going to be helping us for the first 30 minutes or so of this webinar. But to get started, I wanted to let everyone know what we're in for. So this webinar is a kickoff event for the Greater Artificial Intelligence and Oral History Symposium that will be held beginning on July 15th, the work week of July 15th. And so we just wanted to ease some folks into this world if they're unfamiliar with this world, or provide some additional details or some additional intersections for those who are maybe a little familiar with both artificial intelligence and oral history. So in this webinar, we're going to deal with some basic definitions to begin with, and then I'll go through kind of a four-step process of how does generative AI create content. So I promise I'll define generative AI before then. Then James will join us and talk about the resources, interfaces, and some very specific examples that many of us might have heard of or may even be a little familiar with in the world of artificial intelligence, but dive a little deeper into each of those examples and talk more about how they work. Then I'll return and talk briefly about some of these intersections between how artificial intelligence is already being used in the oral history profession. Then I'll give a little preview of the symposium that will be taking place in 2 weeks. And as I said, hopefully we'll have around 30 minutes or so for a robust Q&A. So without further ado, let's get right into it. All right, so basic definitions. Let's just start with what is artificial intelligence? So how do we define artificial intelligence? Some of us may be familiar with the term going back a few decades, actually, usually associated with some sort of science fiction theme. But today, artificial intelligence can roughly be defined as the way for either a computer or a computer-controlled robot to perform tasks that we usually associate with intelligent beings usually being associated with the human race. So these can be things like taking in data and reasoning based on that data, maybe discovering something based on that data, making generalizations based on a set of data. And then, of course, one of the major parts of this is learning from past mistakes or learning from past trainings. Now we have a number of platforms out there that are making waves that can do some pretty amazing things. But I don't want anyone to worry because as of yet, there has not been a program that can match the full flexibility, the full spectra of human intelligence. So there might be, for example, a program like IBM Watson that can defeat the greatest of Jeopardy champions, but when you ask it to take on other tasks, it's maybe not as great. So there isn't one great AI overlord to rule us all yet. So therefore, AI kind of encompasses all of these systems that exhibit some form of intellectual process akin to humans, but again, is not an all-in-one solution. Okay, so right off the bat, I'm afraid I do have to come clean. I did have some help in preparing this presentation today. That slide that you just saw, the text in the slide at least, was generated by an AI. Specifically, it was Microsoft Copilot when I asked it from my menu bar, can you provide me with a definition of artificial intelligence? So it gave me a long narrative in which I could cut and paste. I could go to different sources that it provided me. So that's just a little taste of what we're going to talk about today. Um, so let's get more into just what this artificial intelligence entails. Since the dawn of kind of the current generation of AI, which is generative AI, we've gone back a little bit as far as how we reference different types of AI. So in some cases, we might need to backtrack and say, okay, this type of AI is now something we're going to call non-generative AI. So we're going to start there. Non-generative AI, sometimes this is called discriminative AI or analytical AI. And this could be anything along the lines of a program that can take in data and make some basic predictions on the data, analysis of the data, provide some simple relationships based on the data. But the main thing with non-generative AI, that makes sense based on the title, is it does not create new content. So some of this AI has actually been with us for quite a while. And some of these examples that you'll see at the bottom are pretty common to most of us who live in the digital world. So I'm sure all of us have seen a word cloud. So that a word cloud is generated by a program that takes in a certain amount of text and gives you weights of how often words are used. You may also like, so recommendation engines. So it's based on all the data that you're feeding it. So everything I watched this weekend on Netflix, it's taking in all that data and it's recommending things based on that data. Very simple things that it can do. In some cases, these are really good things that they're doing. So for example, spam filters. So a spam filter might be able to recognize what sort of email you usually get and what sort of email it's been fed that it knows possibly is harmful content, or in some cases, content that is just not normal to you. And then it takes care of us that way. So it's trained through us, it's trained through its system in the first place. And fraud detection. So all the purchases I have on my credit card are registered as data, and my credit card company tracks that. And then it can recognize if there are some weird purchases that don't fit the norm, especially if there's multiple of them at one time. So these are great things. So in some cases, AI has been our very good friend so far. But now we're in the new generation. We're in the generation of generative AI. So generative AI is something that produces this more human-like content based on its training. So the difference here is it not only requires that data training, but it also requires input from a human to interact and generate it. So how this works is we have a human providing a prompt. It could be a simple question. It could be an ask along the lines of, I want an image that looks like this, or I want these three things in an essay with 5 paragraphs, or please tell me the history of the Crimean War. And then it searches a certain set of data. This data could be textual data, it could be image data, it could be media data, whatever this particular AI is trained in, and then it provides some sort of result. It generates some sort of result. So as I said, it can create words for you. It can create sentences and simple answers. It can create an essay for you. It can create music for you if it's trained in media. It can create images for you, videos, and much more. And something we'll talk about later is the larger generative AI programs out there are actually combining a lot of these. They're combining a lot of these types of data to create an all-in-one experience for you. So some examples, I'm sure almost everyone's heard of ChatGPT. We're going to talk about that GPT part more here in a second. DALL-E is an image generator. A lot of you oral historians might have heard the word, or maybe heard the word whisper. So we'll get into these in more detail down the road here in this presentation. But let's get into the weeds a little more about, okay, how exactly does generative AI create this content? So what's different about generative AI? What's changed really, especially in the past maybe 5 years or so? Okay, to explain this, I've got a 4-step process. So step 1, gather lots of data. And these are commonly called data sets in the profession. So a data set can either be scraped or curated. A curated data set is something that you're going to put together yourself to help train your artificial intelligence program, that you're specifically stating, okay, I'm going to give you 100 images. These 100 images are all going to contain X. And then after I curate this data set and provide it to you, you, my little AI, will be able to recognize when you see one of these things. Data sets can also be scraped. So something you might have heard in the news is a lot of the large AI companies are just scraping as much data as they can from the internet. So scraping usually means you're just trying to get your hands on as much data as possible on the general internet that's freely available to these data researchers. And there's a bit of a copyright issue right now regarding that. So we'll be talking about copyright here in a second, but then and specifically with AI as a whole, as far as who owns data, what you can do with data, what's considered fair use, whatnot. So we'll talk more about that in a second. Data is usually these data sets, they're tokenized. That means you have to determine like what is a single point of data, or what's a data relationship that we're feeding into our AI. And we set those with parameters. So for example, if it's an image, we have to determine, okay, how do I determine when I'm feeding something into my AI, it's considering this, okay, this is one image, this is one piece of data, where are the parameters through which I am training my program. These data sets, of course, have possible accuracy issues, especially if we're scraping from the internet. Believe it or not, you can't trust everything you find on the internet. And that's the same for all this scraped data that a lot of the larger AI companies are utilizing to train their full service AIs, such as a ChatGPT. So what does that mean? Well, that means that as great as you can train maybe you have the best algorithm in the world and you're doing great with your company, doesn't always mean you're going to get the correct answer if you're interacting with it as a human. The other issue with data right now is we're running into what are called purity issues. Purity issues usually reference the fact that a lot of the early scraped data that artificial intelligence engineers used was human data. But since that time, we've gotten to the point of where AI is actually generating its own data, and AI's generated data might live alongside the human generated data in the wild of the internet. And that will allow for further scrapes to not be pure human data. And there's a lot of consideration about what this means in the long run for us, as far as the data sets of the future, as more and more AI generated content is available across the internet. Okay, so here's a data set example. It's the STL10 data set. You can go to this website and you can view this data set, which is basically a data set of images. And more specifically, it's a data set of 10 different types of images. So planes, birds, cats, things like that, that has a certain amount of curated data to it that AI engineers can use to train is like, this is this thing. But it also has the vast majority of the data set is uncurated data. So it's data that you can train and test your AI on afterwards and say, okay, now tell me what this is. Is this one of these 10 things I trained you on or not? What are the relationships between any of those 10 things and each other, or any of those 10 things and something that might be in this image that definitely is not one of those 10 things. So this is kind of an example of the type of data that AI engineers are using these days. Okay, step 2, train your algorithm. This is also known as machine learning. So if you see the term machine learning, this is the process through which your algorithm, which is a program that computer scientists or programmers create to do this actual learning. So this is the code that's taking in all these images, learning from these images or text or media, and then generating something. So it's analyzing the data points, it's learning patterns from it, it's learning relationships from it, and then it's generating something for you. And so just as you can kind of curate data, this process and how you're training can be supervised or unsupervised. It can be kind of be curated itself as far as how close of an eye and how specific you are with your training of your AI data. Or are you like just going to open the fire hose of the entire internet and try to train your AI on everything that it encounters? So one quote I really love along these lines is that it's like teaching a computer to recognize cats by showing it 1,000 cat images rather than writing code that specifically defines what a cat looks like. So you're kind of teaching the program itself what a cat is without telling it what a cat is. And the more and more data that it's exposed to, and the more and more interactions with humans later on that are feeding it images of cats, or maybe images of something else, or being asked to present images of cats, all of that goes into the training, and all of that eventually gets better and better of identifying just what a cat is. Okay, step 3, develop a model. All right, so we've got our data set, we're training our algorithm, we're doing some machine learning, and it's learning how to identify cats. So as we're doing that, then we're developing all these relationships. And sometimes it could be text-based, between relationships between a word and the word that appears next to it in a block of text. For images, it could be color relationships, object relationships within a particular tokenized piece of data. But eventually what we're doing is we're developing this model. And so I'm going to use textual data here as an example. So when we're developing this model early on, we developed something called a natural language processing, or NLP model, that use textual data to try and create these relationships between words or between phrases in some cases, so that it could predict either as we're typing. So this could be you on your smart device typing something and it's trying to predict the next word that you want to type. Or in some cases, it might be connected with like a speech to text program that is listening to a ton of media, working with a ton of text, and trying to predict based on the sounds it hears what sort of text is supposed to be generated as a transcript of that sound. So we've been dealing with natural language processing for a while now, but again, more recently, we've had a bit of a jump, and we're in the era of these generative pre-trained transformers, or GPTs now, that are more intricate algorithms, more intricate models that have expanded these relationships. So instead of maybe a relationship between a word and a word, we're having relationships with whole phrases amongst each other, or in some cases sentences. And we're developing models, some of these large language models now, in the natural language processing world that enable us for much more coherence. And this works on both ends. So this means something's more accurate if we're feeding it information, if we're feeding it an audio file, if we're giving it a block of text and then trying to develop a piece of text that's like that. But it's also interacting with us as the humans who are putting in the prompts and being able to understand what we're asking for and then being able to create the thing that we're asking for. So these things are working in tandem now. So this is a kind of an intricate slide, but it kind of shows you on the left here, the timeline of we had very basic models of natural language processing to begin with, even something that we call the bag of words and word embeddings. And we've kind of been evolving for a while now to the point to now we're at this transformer, the GPT model. And what the GPT model enables us to do is to work with something that's called vector data and vector databases. And the best way I can describe this, and this might be a good thing for Q&A later, is it's kind of a generation of data in a database. So like the earliest databases might have been, I'm going to store this in the database so it's safe, and then I can come back and find that thing. And then the next generation of the databases, I'm going to store a number of different things and relate them to each other. And then the current generation, the vector databases, we're thinking as kind of like three-dimensional, thinking in 3D, as far as relationships between this data that aren't succinctly apparent. It's like not the same word, not the same bit of data as far as a piece of music or a video or an image, but it has this relational data that you see on the right, where it begins to create these kind of vector matrices within the algorithm, within the model, and it begins to learn how these phrases interact with each other, how these images and media interact with each other. Okay, and our final step, profit. Well, that's what maybe some AI companies are really licking their chops for. But really what it is we enter a prompt as a human and we create something. So this is the last step. This is what gets us to the generative part of generative AI. And again, I'll continue to use the cheap GPT use case here, textual data. So what does this mean? So anyone who's used ChatGPT might recognize some of this, but here are some different things that your AI based on textual data that's using a GPT might do for you. So it might be able to just flat out create things for you. So someone might give it a prompt and say, I want 10 social media posts about this particular topic or this particular thing in the news or whatever. And it might be able to spit out something based on all the data, everything that is crunched off the internet. It might be tested in different styles of data. So one thing you might have come across is like, I don't want just King Lear, but give me, the first, 1,000 words of King Lear in the style of Eminem or something like that. And it will not only be able to go back to its record of the text that it was trained in the works of William Shakespeare, but maybe it was trained in all the works of Eminem. And now it's giving you lyrical verses, but in a more common hip hop style. And then you can throw in different emotions in there as well, like humorous, professional, angry, things like that. Code. So a lot of programmers out there were kind of excited, especially those that didn't want to do much work and say, hey, complete my code for me. I give you a big chunk of my code. I can't figure out what's going on. Analyze it for me, maybe suggest what I should be adding to it, whatnot. There's been a bit of a halt on this from a lot of companies that actually do code work because maybe some of those people didn't realize feeding it into these AI programs, you're basically giving them the code that you're working on. And most people that are working on code are working on proprietary code, and they don't really want that out into the greater world, let alone maybe a competitive company. And then summarization. And so this is something that has been used a lot with textual GPTs. So you have a block of text, either that it's already trained on, like I said, King Lear, give me a 3-paragraph summary of King Lear. Or maybe you go back to a particular piece of text that you might have. So for us, it might be, okay, I'm going to feed you a transcript of this oral history. Give me a 3-paragraph summary of this oral history. So again, it's not just the data that it's trained on, it's also the methodology that it's trained on. And so it might be able to say, okay, let me get this new piece of data that you just gave me and create the same effect on it as a summarization as I would all this other data that I've previously been trained on and that I can also summarize at the wink of an eye. So that's kind of your 4-step process of how our current generation of generative AI works. So hopefully I didn't lose too many of you there. And at this point, I'm going to take a pause and invite James Fowler in for the next section of our workshop. Stop sharing. Welcome, James.
Hello, hello,
And
everyone. And
James
go
is
ahead.
going to get into some more concrete examples for us. But before then, he's going to share some resources and interfaces of how we actually interact with this AI and where we can find it on the internet. So take it away, James.
Absolutely. I generated this image using DALL-E 3 through Microsoft, and I thought it was really interesting, even just the labeling of the books that it came up with as resources, how it spelled lots of them, what it thought was important. It took me a long time to figure out the second one from the bottom is supposed to be biology, right? So Um, as with many things and many new technologies, we find that they're not they're not always fully baked when they first become available to us. Let's talk about resources, things that we need or can help us with this. The first thing I'm going to talk about, and some of these are um, both helpful from a terminology perspective as well as from an understanding perspective, is free and open source software, right? So free and open source software started back in 1988 was the initial idea, and it was in response to all the proprietary software. Basically, lots of academics, especially, were trying to do things with their students and couldn't because it was all controlled via copyright or otherwise encumbered. So the free and open source software movement started, and today we have so much to thank for that. One of the things you may hear around it is this disambiguation in English. So in lots of languages, you can distinguish between something that's free, as in liberty, not encumbered, not prohibited, and free, as in giving away, right? No charge. But in English, we use free to mean both all the time. So if you ever hear free as in speech and free as in beer, that's the disambiguation that you're hearing when looking at software or tools or things that you may want to use, right? Free and open source software are tools that anyone can use, especially outside of a commercial space. Some of them can be used in the commercial space. It depends on the actual license that's being applied. And what they found is that people could steal the code that they were making available, the software that they were making open and available. And so they started to use the law to protect this software, right? They started using copyright to protect the software that they were creating and giving away through licenses like the GNU Public License, or the GPL. You may have heard of the MIT license, the Apache license, the BSD license. There's quite a few of them, and they all serve different niches legally to define kind of what you can do with the software that's being made available, right? Most of them require modifications be shared. So that if you make a change because you need it to do something that it's not doing, then you can share that back. And then everyone benefits from that sharing. Typically, they have large communities around the software, and they're really very accessible. On several occasions across time as I've been using open source products, I've emailed the list saying, hey, I've run into this problem. Has anyone seen this problem? And I find myself in a conversation with the guy who started the project. Some of these guys are very impressive and typically very nice, right? People who want to share things, I find for the most part, are really nice. Open source software is everywhere. You are using open source software today. There are parts of open source software even included in Zoom that is hosting this. If you use the Chrome browser, right, that's built on the Chromium open source project. Firefox, formerly known as Netscape, for those of us who might remember that far back, is completely open source. Android, if you have an Android phone, then you are using open source software. If you visited a website today, chances are that you are, using Linux and Apache, whether you knew it or not. Right? If you use Audacity in your oral history work, then you are using open source software. And if you're using Whisper, you're also using open source software. And we'll continue to use Whisper. I'll continue to use Whisper as an example. One of the things that they ran into as this free and open source software exploded was trying to keep straight and make available this software, but in ways that everybody could work with it. If you looked at version numbers of software back in the early days of the internet, it was version 1.0, 1.0A, or 1.02, something like that. The version number off of the browser I'm using is 122.0.6261.132, which is kind of crazy to track. And for that, we kind of needed tools in the community. We're going to talk about GitHub. That's GitHub's logo up in the upper left. And they're tools for managing and sharing software. They're focused around source code, which is the programs, and often they share, the program itself compiled. Just depends. You can go on GitHub. Anyone can go on GitHub and find out. It provides version control, bug tracking, feature requests. Whisper is hosted on GitHub. It was released by OpenAI, which also makes ChatGPT, and given to the community. This is OpenAI's Whisper page on GitHub. This is what it looks like. Some may find it a little intimidating, but things are really very well labeled. In the upper hand corner here, let's see, yes, is where it says fork, right? That means if I want to take my own copy of this as it stands today, I can make my own copy of it and I can do whatever I want with it. Or I can just download and use it from OpenAI, upper left, Whisper, right? Name of the people. If we scroll down a little more on OpenAI's Whisper GitHub page, we find it talks about what Whisper is. It tells us, right? So we're going to know what it is this software does. Right? You can find Audacity, you can find other projects on GitHub as well. And I only included part of this image. If you want to look at more of the image of how it works, you can go to Whisper's GitHub page and see it. Also give a Colab example. We're going to talk about that a little later on. Aside from talking about the software, what it is and what it does, it's going to give instructions for how to set it up and use it. Don't be intimidated. There are lots of different ways. You don't necessarily have to install and use the command line to do it, or other tools to get and use the software. But if you want to, the instructions are there, right? And any questions you have about them can be asked and answered there. Those are part of the tools that GitHub provides. Another thing that's interesting to note, if we look to the bottom here, it says it requires FFmpeg. FFmpeg is an open source project that's been around since about the beginning of the internet. If you want to do anything with audio or video, especially if you're an open source project, but even if you're not, it uses FFmpeg. It is the Swiss Army of all digital representations of audio and video. And you'll find it used by Audacity and by other open source projects. Because they're all open source, they can use and rely on each other. It's I can't remember the phrase that I wanted. A virtuous cycle. There you go. What made GitHub great for software made it not necessarily great for AI, especially in the beginning. So Hugging Face came about, and it really is called Hugging Face. And this is their logo in the upper left there. It is the GitHub for AI. Presently, there's 739,048 models there, all different kinds of models focused on all different kinds of data, but they're there. Anyone can get them and use them. You may have heard of like Meta released their free, their open model. It's called Llama. There's a number of different versions of it, and you can find it there. Stable Diffusion, Whisper, all of these are found on Hugging Face and can be accessed in different ways. It can be accessed directly, or they can be accessed via something that's called API, which we're going to talk about in just a minute. The tools for working with and or training models are there too, if you want to understand how a particular model was made in detail, or if you want to try making it on your own, you can do that on Hugging Face. This is the Hugging Face page for the Meta Llama 3, so version 3, with 8 billion parameters model. You can see the license information here on the left. In the last month, it was downloaded 2,711,000 times, right? It's 8.03 billion parameters, and it gives information about how to interface with it. You can access it, remotely interact with it on Hugging Face, or you can download it, all up to you. There are also here links to a number of tools that might be useful, you might need in working with this model if you were to work with the model, right? Again, don't feel overwhelmed by the page. Anyone can go and look and read these pages and learn, what the things mean, or just to get access to the models. Earlier on the Whisper page, it talked about the Colab version being available. This is referring to Google Colab and Jupyter Notebook. Jupyter Notebook, I forgot when they started. They started quite a while ago. Originally, they started as a tool to support open standards, right, for interactive computing across programming languages. That means, okay, I'm going to write this in C++, or I'm going to write this in Java, or I'm going to write it in Python, or whatever all these languages are that we don't want to have to know about. And if I make a collab for it, I can share that collab, and people can then use that software without knowing about those programming languages on whatever computer that they want to, right? So lots of companies signed on and have made their own, because the Colab Jupyter Notebooks is open source. Amazon makes their own SageMaker. Google Colab makes theirs called Google Colab. Microsoft Azure Notebook, and there are many, many more, right? So when you see it talking about Colab or a notebook, Jupyter Notebook, that's what they're talking about. They're talking about this basically open way of sharing research data and software, right? It's become incredibly popular, right? In 2015, there were 200,000 notebooks. By 2018, there were 2.5 million available. And by 2021, 10 million available. It's actually helped with the reproducibility issues in sciences, right? And these notebook files, they use a standard called JSON, which is JavaScript Object Notation, which basically is the modern XML. For those of us who have ever had to deal with XML and its rigidity, JSON is the modern XML, but without the rigidity that it had. This is an example of a Colab page, right? If I want to run Whisper, I don't need to figure out how to program in Python to do it. I can just use this Colab and run it on Google, right? This is is the one. I keep trying to scroll this page. The bottom right, if you scroll down, there's a run button. it makes it much more straightforward to use software, and it's another way that they go about trying to make software available, right? So there are lots of different interfaces to software, lots of different user interfaces. Sometimes you'll see just UI even, and that means user interface. They're graphical, command line, and I'm going to include API here that we talked about a couple of times, because even though it's not a user interface, it's still often driven by user interaction. This is a GUI, a graphical user interface. This one's from Star Trek. One of the reasons it may look familiar to you is because it came out before the iPhone came out, and there's a lot of elements that have been adopted by a lot of different software projects. So it looks similar and looks familiar, even though at one time it was, radically new and modern. Not everything has a graphical user interface. This is a command line interface. This one's from a Mac. And again, showing someone who's installing Whisper. You can see right there, before I'm moving my mouse, pip install Whisper. And then they're doing something, Whisper help. One of the great things about command lines is if you ever want to know, like, oh, it's not working, or I'm trying to get this to run, how do I do it? You can always use that -- help, except on Microsoft, in which case it's /help H to get help. One of the advantages of command line, and the reason that you may want to use it over a GUI, is because they tend to be more powerful. It's just hard to represent all of the options available in software in a graphical user interface and still have it be uncluttered and usable. So while you may find a GUI to be easier, it's often a subset of what can be done, and the command line will give you access to those options. So if you are trying to do something and not being able to do it with your GUI, check out the program. It may offer that. Really quickly here, API, Application Programming Interface. Okay. This is what enables programs to exchange data. And anybody who has an API has a document listing what it is and how to interact with it. You use APIs every day. Every single person here, without a doubt. Not just the ones that I know, right? You are using APIs every time you use a web-based application, right? Google Docs. If you're using any kind of web email, Office 365, anytime you click, it's using one web software, and then it's requesting information from others out there. Many websites nowadays use APIs as part of how they work in order to access data in other places available from other companies or other groups. APIs are important not to understand how it works, or specifically what that specific API is, but just that they exist in how you can access or interact with data. Some specific examples of AI, right? And now for some models. And I shared this with my family, and they explained that I needed to be explicit, that my joke was a little too much of a dad joke to maybe be comprehensible. But these are all models, not the models that we've been talking about per se. All of these models were generated by a single prompt to DALL-E 3, which is via Microsoft's Copilot. Right? For some reason, I have no idea why. If you ask for a group of international models, you receive a soccer ball. There are these interesting artifacts out there. Right? So these models were generated by a model. That's the joke. DALL-E, DALL-E 2, DALL-E 3, etc., all DALL-E, as those images that we just saw. It's a deep learning text to image model. It was released in 2022, and it's built on a GPT model. right? It's closed source, can only be run online with subscription. Originally, there was some beta access, but that's gone. The only free way to access it now is through signing up for Microsoft Copilot, and um, and it works on GPTs, which is one of the models that Stephen discussed, right? In this case, text to image. It was trained on large data sets of both supervised and unsupervised. So labels that had images that had been labeled and some that had not been. It does a text for pixel swap, right? DALL-E was improved on by DALL-E 2. One of the ways that they did was to add a diffusion model layer to help better select matching images. And one of the ways they've improved models as they've gone along and worked on them is by adding additional types of models, squishing them all together basically, so that when your prompt comes in, it's run through several different models in order to get you outputs, right? Things that better match. Right. This was a prompt from a recorded interview between intergenerational family members in the style of DALL-E. This one is an interesting one. An oral historian conducting an interview with a church elder, right? Generated on DALL-E 3 via Microsoft Copilot. You can see some of the issues that it has in generating these things, right? The interviewer has a microphone. It doesn't look like he has a left hand. The microphone is magic. It incorporates cord, power, and recording all in the microphone. And unlike we typically would find in an interview setup, the interviewer does not appear to be the one taking notes or noting anything at all. Was interesting when I ran this prompt through DALL-E 3 again, because this one's from March. It generated 4 different images. 2 were of female interviewers, 2 were of male interviewers. All of the, I guess, when interviewing a church elder, all church elders apparently are men with white hair, but then it gave basically representations from 4 different religions in each of the squares. It was kind of interesting. Stable Diffusion is a deep learning text image model that was released in 2022 based on diffusion techniques, right? It works very differently than GPTs. It is an example of generative artificial intelligence. One of the great things about Stable Diffusion is that it's open source. You can download it and you can run it, right? Without getting into too much detail, Stable Diffusion works by removing noise, right? It starts off, you can see in step 1, it starts off with a bunch of random noise, as random as it can possibly generate. Then it starts removing the noise across the steps. And if you look closely, you can see how it added things in and then moved them around or removed them in later steps until it presented what it's deemed to be the best image. Right, and this is an example of diffusion of one type of a model and the way that this particular model works. And one of the great things about it is that you can download it and use it because it's open, and there's also a wide community around it. Let's talk about ChatGPT. Right, it's a chatbot, virtual assistants that uses OpenAI's proprietary GPTs. Right, it's been fine-tuned for conversation. Fine-tuning means that after the model is generated, that model has then had additional data applied to it, or it's been used to analyze additional data. Right, it's very specifically set up for text queries and responses. That's how it works. When we're using ChatGPT, right, we do put in a prompt, like what question should I ask in an oral history interview, and then see what it puts out. One of the things to remember across all of these models, using all of these, is to save the output that you get, because unlike kind of math or even some of the non-generative models and non-generative AI that Stephen talked about, you won't get the same answer every time. In fact, every time you're almost always guaranteed to get something different, which is good for trying to ferret out information, but not good for other things. It, all of these models, and especially seems the bigger they get, the more susceptible they are to something called hallucination. And that really is the technical term for it, hallucination. Um, GPTs especially like to hallucinate. That is, they like to make up data. We conducted a test with a prompt requesting a summary of data available on a public website with some quotes from that data. It came up with 4 quotes. It summarized, it had a nice introductory paragraph and some commentary and then a conclusion. The only problem was that a couple of the individuals were completely made up. They didn't exist on that website or anywhere, along with the text that was attributed to them. Right? So they try and do their best, whether or not the information they're presenting to you is valid, because for them it's mathematically valid in the backside, and that is first and foremost what they're concerned about. They don't reason like we do. Whisper, right? Natural language processing. It's a weakly supervised, which means there's some supervision there, but mostly not supervised. It's built on an encoder decoder transformer, and we can handle some of those in the questions needed. Right? It used 680,000 hours of multilingual data, 117,000 were non-English audio. One of the really interesting things to note about Whisper is that it's used for speech recognition and sound recognition. When Stephen was talking earlier about parameters and about tokens, right, it breaks down the sounds that are being made as people speak. And it is able then to use those sounds down to phonemes, right, to reconstruct both language, and in some instances where it isn't able to pull out an exact match, it will do a nice representation of those sounds, at least in English. We have a lot of audio in our archive that has a lot of either heavily accented, foreign names, foreign name place names, and Whisper does a surprisingly good job of actually identifying them. And when it doesn't, it comes up with something typically where you read it or read it out loud and you understand what it was trying to come up with. There are lots of different ways of using Whisper, right? One of a popular way in the oral history community is via Mac Whisper, because it's really straightforward and simple and really inexpensive. So if you're using Macs, there's the link. You can get it from lots of other people. I don't have a Mac, and we don't use it via Macintosh. We don't actually run it on Windows either. Sorry, I clicked on my other slides. This is what Mac Whisper looks like. Nice GUI. Tell it where the files are. If you want to do it in a batch, so you can set it and go away and come back later, because sometimes it can take a while. There you go. This is how one of the ways that we run Whisper. We run it in a command line. Okay? It's set to that we can say Whisper and the audio and any other things that we want on the audio. Um, there are other ways to set that up, but we run it from the command line, and it gives a lot of information. And I can keep that information turned on, or I can turn that information off. That's all up to me. But there's no reason for it to be intimidating at all. Really, it is. It's easier than you think, and we talked about GitHub and Hugging Face and all of these. They don't they don't care if you make mistakes or if you do something wrong. You can't break anything. So knowing that makes it easier to try, right? No. Stephen, if you want to talk about how AI is used in oral history, I'm sure this is going to cover more whisper.
Yes, absolutely. Thank you, James, for all those great sections. And yeah, you can just okay, I'll take care of it. So let me share my screen real quick with my slides. So we have three sets of slides going right now, but we'll get there eventually. All right, here we go. Okay. So hopefully you got a great sense of just how all this stuff works. James gave you great examples of how you interface with it, where you can find it, and then some of the primo examples just in the wider world of AI, in some cases closed source, in some cases open source. So how is artificial intelligence used in oral history? And more specifically, how is it currently used in oral history? Well, I kind of put this slide together of some of the things that I've seen in the world of AI, or things I've seen discussed, or maybe some things I'm doing myself. So the first category here, I have transcription, captioning, translation assistance. Okay, so uh, most of us who deal with oral histories, one of our primary concerns is once we've recorded that oral history, how do we get it into some sort of textual form, either to facilitate our video oral history, or in some cases to facilitate an audio oral history, or just a standalone transcript or index. So how can AI help with that? Well, there's different ways in which AI comes to us for this aid. In some cases, it's built into other programs. So Microsoft has been doing a lot of updating and trying to hawk their Microsoft Transcribe service. Anyone who's used Microsoft Transcribe in the past can tell you it wasn't too great, but now Microsoft owns half of OpenAI, which is ChatGPT, Whisper. So they have more to throw at it now. So it could be just within your Microsoft suite. Microsoft is trying to help you with these tasks. Zoom, we've got a closed captioning service working right now on this very webinar that will be turned into a transcript after the fact and will be available to you hopefully sometime tomorrow on the OHA website. So that's just built in to these other programs that have other primary functions. Then you have programs out there that are kind of sold as add-ons to add on to maybe a video teleconferencing service or some other media-based service to develop transcripts for you. So like an Otter AI, some of you might be familiar with that. There are dedicated programs where it's just pay for our service, upload your media to us, and take care of it there. It has nothing to do with actually recording the interview. It's not trying to help you out as part of the process. It is this service, and this is why we exist, to sell you this service. And so those of you who know Rev is the all-encompassing company that also includes a product called Timmy. Timmy is the automated speech-to-text program, the AI program that creates the raw transcript that you can then either edit yourself, or the Rev team will actually ask, do you want to pay us for a human to provide that last layer of editing? Trent is another example. Trent has a service where you upload content, you get a transcript, and then they have their own editor in their suite of services. So if you wanted to go ahead and edit – what you need to do there before you even export it, you could do it there. And then, as James talked about, the open source variants. So a Rev, a Trent, even an Otter, that's going to cost you. A Zoom, that's indirectly costing you. Microsoft 365 indirectly costing you. Whisper costs you basically the energy to run it. And there is a lot to be said about how much energy we as a human species are using to run all these powerful AIs. But for you as an open source code, you install it yourself, you use it on a Colab environment, Mac Whisper, however you want to, and then it's yours. Also, it's local. So that's a big thing, a big difference also, because there are ethical concerns all across this presentation, but one of them here would be who has access to your stuff if you're allowing someone else to transcribe it for you. If you're using something like Whisper that's locally sourced, that's I can put it on my laptop, I can go out in the middle of the forest, run Whisper, no one will know that I'm creating a transcript with that media. Okay, that's transcription, translation, captioning. There are other file types, ways in which you can get that into different types, SRT files and the like. Transcription analysis, maybe content analysis. So instead of just producing the raw material, analyzing that material. And some of this is that non-generative AI that I talked about before that we've had with us for quite a while. If anyone's ever used NVivo, that's what it's all about. So things like word clouds, direct relations between words and phrases, sentiment analysis. Sentiment analysis is this sentence or is this phrase positive or negative, and then analyze it across an entire oral history. Is this oral history positive or negative on balance? How do these 12 oral histories in your project compare to each other? When is sentiment negative or positive when discussing certain topics? So you can pull this analysis based on data, based on this AI, without even reading it. And then you can dig in and it's like, okay, why is this coming up? What should I be looking at here? Even mid-project, you can say, I've done half my oral histories. Everyone seems angry when I bring up this topic. Maybe I should do a little more research. Maybe I should dig into this more with my future interviewees. GPTs providing summaries or indexing. So I talked about summarization of text. So I at Baylor use Whisper, Mac Whisper specifically right now to create transcripts, raw transcripts that our students then edit. The next step, possibly, of including AI in my work is running all of our transcripts through a GPT for indexing to generate a raw index, which our graduate students would then edit. Because heretofore, indexing, the summarization that we do for our oral histories, has all been human, 100% human created. And anyone that's done indexing before will tell you is like, I could have five-star students working for me. If I give them the same interview and ask them to index it for me, I'm going to get 5 different indices from them. They might all be great indices, but they're all going to be different. So how do we normalize that procedure? Well, maybe AI does that for us. Any of you familiar with the Showa Dimensions platform? They came to OHA one year and people were able to try it out. This is Showa, the USC collection of Holocaust survivor testimonies, not just from the Holocaust, but from genocides all across the world, but specifically sitting down with one interviewee, asking them a barrage of questions in a sphere of microphones and cameras, and generating a hologram through which future individuals can ask questions of that interviewee. And all of that data that has been processed from all of those questions and all of those angles not only generates a lifelike hologram in front of them to correspond with, but also able to actually interchange with you. So instead of a textual input into a chat GPT, it's an oral input into the Dimensions software that will then make the hologram actually respond in kind with one of those data points. Interview assistance. And so this is where we start to transition a bit. So what does this mean for other parts of the oral history process? Can we utilize AI? Should we utilize AI in other parts of the process? Do we have automated interviewers in our future? Uh, are oral historians at risk? Are we creating chatbots to conduct oral histories? What are the pros and cons there? Can they conduct more oral histories because they're just a machine and they're always available? What's the quality like? What are the biases, one way or the other? So these are all sorts of things that are either currently available to us, might be available to us in the near future, or are already being tested and thought about. And as such, that's a good segue into a little bit of a plug for the upcoming Artificial Intelligence and Oral History Symposium. So if you're not familiar already, we are putting on a week-long symposium of 10 different panels starting July 15th, trying to tackle a lot of these issues. In some cases, sharing examples of work with AI, in some cases, just ruminating about AI from that legal ethical sphere. So we'll be putting on this symposium in a couple weeks. You can go to our website, scan the QR code there if you're interested in registering. 10 panels, morning panel, afternoon panel, each day, Monday through Friday, July 15th. All will be recorded. All will be made available afterwards, probably that next week recorded, so you don't have to attend all 10. But just a little bit of a taste here of the types of things that we'll be talking about. The entire program is available online. But as I said, there's several ethical centered panels. So everything from what does big data mean in the world of oral history? What does it mean when we have automated speech to text transcribe something for us in a particular style that it's trained in? What does that style mean versus the actual representation of the individual on the page? And this can be different forms of English. We talk about whisper and what it was trained in. It was trained in other languages too. Different types of dialects, how it's representing people from different backgrounds, ethnicities. And then we have more concrete examples of panels here. So a panel about indexing, several panels about whisper, its use in different projects, making a case for humans in this sea of AI that we see here. So a really great all around program of panels here coming up July 15th. So we really do hope, if you haven't registered already, that you'll join us. But with that, I am more than happy, and I'm sure James is more than happy to take any questions you might have. So we had a few questions come through in the Q&A window. Keep throwing questions in there as well. Let's try to prioritize Q&A rather than chat. But then I'll just stop sharing my screen, and then we can just, James and I, and Sarah is back. Hello, Sarah. Sarah's back to help us manage Q&A. So Sarah, if you want to facilitate Q&A here, that would be great. Thank you so much.
Sure. I know James volunteered to start with at least the first question, so we can, I think, just kind of go in order.
I love questions. They're my favorite. This one is both easy and hard. The question is, how do you correct the example of Dali, like with the church elder, to make it realistic or to better match what you want in the photo? And that's one of the big challenges of working with image generation programs, and with any of them, is how to write the prompt in a way that you can coax the model to give you what you want. Typically, in my experience, you start off with your prompt, and then there are a couple of different ways. Sometimes you can select an image and say, I want it like this, but with these changes. Or you can modify the prompt directly and have it attempt to generate new images based on the additional information that you provide. But those are the ways that you kind of go about working with it. Alternatively, if you get it close enough, right? Never let good enough be the enemy of perfect, or never let perfect be the enemy of good enough. Let's hit that backward. You can take that image and then pop it in GIMP if you want to use open source, and there's several others besides GIMP, or Adobe Lightroom or something like that, Photoshop, and make additional changes right? You can still do that. And a lot of even graphic artists will use generative AI like DALL-E or Stable Diffusion or something to get a base image, knowing that it's not going to be exactly what they want, but it's going to be good enough. And then they'll take from there and edit and make the changes that they want. So I can keep going if you want. I really do actually would like to answer this one for Daniel. And then, Stephen, I would like to hear your comments too from that copyright conference that you, or meeting that you went to. One, I don't know if it's accept or not accept. We use the terminology because it lets everybody know that we're talking about the same thing. That's
Go
why.
ahead and go ahead and read the question, James.
Oh, yes, good point. Sorry, thank you for reminding me. Isn't it problematic to accept industry terminology without question? Scraping seems to be just stealing, and hallucination seems to be major errors. The scraping has been happening as long as the internet has existed. People in the early days of the internet were like, whoa, I can just view source and copy someone's page entirely. And you could. And while it's harder to do that now, you can still get any information that's displayed publicly. And it's a difficult question as to whether scraping constitutes stealing or not, right? All of this information is available publicly. If someone leaves a newspaper lying on the street and I pick it up and read it, am I breaking the law because I didn't buy that newspaper? Or if I like, oh, check out this article, and I stop at my neighbor's house on the way home and say, oh, here, read this. I saw this in the paper and I thought it'd be interesting to you, and here's the whole paper. Am I stealing? This was made publicly available. Is it because I gave him the whole newspaper instead of just ripping out that article and giving it to him? A lot of these questions are actually winding their ways through the courts right now to try and make those determinations, because it's the first time that we've been able to do this kind of thing. Mary Meeker, who's an interesting person, was commenting and said that basically, in many respects, the first 30 years of the internet just seem to have been around in order to generate the data sets large enough to be able to enable these models, GPTs and other models, and AI. As far as hallucination goes, hallucination is fascinating. We call it hallucination because we're people and we understand things one way. But when you break everything down mathematically and then say, okay, use that math, those determinations that you've made about those relationships mathematically, and give me something that relates mathematically to what I'm giving you, which is that prompt, and it gives you that. Now, it may not be valid to us always, and they continue to do lots of work. Like the difference between DALL-E and DALL-E 2 was the addition of a diffusion model. So you would get the generative pre-transformer that would generate images, but then it would use a diffusion model to also generate images and then do a comparative analysis between the two, and then select those that matched in order to bring those forward and give those to you. Right. So there's a layering of models as well to try and control for that hallucination. But the hallucination is not necessarily a major error. It's doing what we asked it to do. It's giving us those mathematical relative representations, but they may not be what we intended, because our meaning is not always clear. Model, right? What are we talking about? Are we talking about, people on glossy magazines? Are we talking about, model for political development? Like, when we say model, we can mean so many different things, and it may or may not be represented or classified the same way in the training data. So it's a challenge. It's not an error. It's trying to understand things differently between two groups of, if you want to terminate it or term it intelligence, you can, right? Like, I've often wondered how you see all these awesome octopus things, right? Like where there's an octopus in Australia that loves to take pictures of visitors. They set it up with a little camera, and when people go and they stand in the little square, the octopus is like, oh yeah, it goes over and takes pictures of them. And all of the other problem solving, but we still don't know how octopus intelligence works. we don't know how they think or get to that. And it's the same thing with these models. Um, we understand there's math going on, but there are a lot of times that we don't know exactly how it figured that out. We're just happy that it did.
All right, I think we have about 15 minutes left for a whole host of
Oh,
questions.
there's a lot more questions. Sorry,
More questions. You're okay.
there weren't
Stephen,
that many to begin with.
Yeah,
what is
real quick, I'll do a little plug first, and because I saw Ginny Batts in the group today, and so she invited me to a webinar last week that talked about, from the Association of Moving Image Archivists, their copyright committee, talking about AI and copyright. So that's one of the reasons I included it in my slides. Is some of this is scraping stealing. So as I said, on the front end, we got scraping. It's training. It's utilizing data to train models. Is that stealing? Is it stealing the data, or is that intellectual work being done by a machine? And right now, what we're rolling with in our legal sphere, at least the US legal sphere, is that is covered under fair use. Now, there are major content developers out there who do not think that's true and are suing the major AI programs out there and saying, no, this is stealing. On the back end, you
And it's
have,
transformative too.
yes, on the back end, you have, okay, give me a picture of a church elder. Okay, can I then use that picture and copyright that picture? Now that's my content. I told it to do something. It generated something for me. Is that my content? On
all
that
right?
end, on that
These
end,
are definitely what we're going to talk about during the symposium coming up in more depth too, right? Like
right,
Yes.
we'll have
exactly.
space for some of these expansions.
Yeah. So my point here is, there are legal cases on the front end. There are legal cases on the back end. The legal process, the gears turn slowly. In that particular webinar, the estimate that there's about 20 of these cases out there, might take 8 to 10 years to get to any sort of actual ruling. So is it stealing? We still don't know from a legal sense.
Do you want to answer the next question about Mac Whisper, Stephen, since I think you knew more about it?
Yeah, so I'll read it real quick. So Mac Whisper specific question, which, by the way, I will say right now, I recommend anyone with a Mac that wants to try Whisper to use Mac Whisper. It's a one-time license fee. Even though it's open source, they've built a lot of stuff around it, and it's really useful. Why is the formatting so bad? Last time I tried, I got one long block of text. Other AI seems to have gotten this okay between speakers. So speaker diarization is what we're talking about here, and then the next comment, I believe. So how long is it until we were able to get to this level? Not just for great diarization to say, okay, this is this person speaking, this is this person speaking, whatnot, but also until we can reliably transcribe and summarize when preparing for archive. Okay, so this is true. I'll give a little bit of a flip side here. I actually don't mind the block of text, because I give that to my students, and then one of their tasks is to break it up, and it helps them in their overall process, because Mac Whisper is so accurate, they can go sentences without having to change anything. And this new task that my students undertake of having to clean up an automated transcript rather than transcribe from scratch, it's a different set of parameters for them as far as how they learn how to interact with these raw transcripts. And so for me, being able to tell them, okay, stay in tune enough to be able to break up when there's a speaker change, kind of helps them stay engaged with the interview. So that's just a little aside for me. When are we going to achieve, 98, 99% accurate speaker diarization the same way that we have with the actual content of the transcript? I don't know. It's one of the holy grails right now. Maybe James does.
We have that working. We have that working using Pi Audio, which is another open source project. It's published on GitHub. I can give you the GitHub link if you want, but it is all command line. And it works with the Whisper medium model. With the large model or the small model, it has problems. But with the medium model, it works well at actually getting everything and diarizing it properly. because Whisper doesn't have that in. And, you know, we often are like, oh, here's the software, great, you know, it works or whatever. Sometimes, you know, software often is a lot more complex
Mhm.
than we give credit for.
And it depends on the format as well. So this format we're in right now, we have different speaker channels, so it knows who's speaking from one to the next. So when we generate this transcript, we'll have great speaker labels because it knows it was coming from this particular channel, which is labeled with Stephen Sielaff or James Fowler or whatnot. As far as the indexing, I'll have to get back to you on that because I haven't personally started with that. I don't know if James has.
Oh, no. No, I can envision how to do it, but and actually, I think that will be better answered at the conference, at the symposium that's coming up.
We do
I
have a
think there's
couple
some things
panels on this topic at the.
that are going to be talked about there that are not necessarily publicly available. I was going to say something and then I didn't, and I'm so glad.
We're harnessing what we can do today. Stephen, there's also another question about Whisper handling accented English.
It does great.
Whisper does great on accented English.
We have heavily accented English. Some of ours are not, a number of them are non-native English speakers or people who will just switch into a foreign language. With, you know, it's all the diplomats. And so and it has shocked me how well it does.
So I'll give you a very recent example. This happened last week. We found some old Betacam tapes of a local Jewish synagogue's women's group and some interviews with that women's group. And they were like rapid fire interviews, and they were all in English except they got to the very last interviewee, and she was speaking, we believe it's Russian right now. And she had someone translating next to her. Whisper recognizes, at least again, if we confirm this, recognizes she's speaking a different language in this primarily English transcript, and says when it's speaking in Russian or whatnot, but then is going back and forth between the three, between interviewer, translator, and speaking in Russian. And so it can do a pretty good job of identifying those things. Now, another holy grail would be doing a great job of actually translating on the fly with multiple languages in the same audio. So that's something that we're still working towards. But it's Whisper does surprise me almost on at least a monthly basis.
All right, let's look here. I don't know which one of you wants to answer this, but the question is, could you discuss options for speaker diarization where the AI model recognizes and breaks up different speakers? That's what you just talked about.
That's what we were kind of just talking about. Yes.
Okay.
I can mark that down. There you go.
Moving on. Can you talk more about ethical concerns of some of these transcription software that use AI and best practices for navigating these if generative AI is being used in consent from interviewees release forms? That is a really good question that comes up all the time.
I mean, ours that can sum up pretty quickly is one, we're either processing the audio in-house locally, so it's not exposed at all, or if it is exposed with an outside service, we have a contractual relationship with them that requires that all of the data exchange be private.
Mm-hmm. Yeah, and that was a big kind of a game changer when Whisper came on. It's like, oh, this is something that's completely closed in your environment, and it doesn't matter if everyone wants everything to do with this oral history project out into the open, or if this is the most locked down oral history project in the history of man. You can take care of that both locally on whatever machine you decide to choose, and keep it amongst only those who are authorized to look at it. As James said, a lot of the services you have to realize you're uploading to someone else's server, computer, or whatnot, the content of the audio, video, whatever you're transcribing. And so you always have to think about who has access to that audio while you're working on it and what they're going to do with it long term. So like James was saying, it's like, are they going to delete it as soon as I'm done with it? And I don't have to worry about them holding on to that. You also have to think about what they are doing with that besides generating a transcript for you. They could be using that content as more content to train their own AI.
Read the fine print.
Yes. But again, if you're using whatever version of model of Whisper you have installed on your own computer, that's not going anywhere. That's just staying local to wherever you're using it.
All right, we are about 5 minutes from our goal to end on time. So maybe we can get through a few of these. Seems to me that this demonstrates that 2 OH jobs are on the horizon: scientist, technologist, and the humanitarian. There's no reason to believe someone's job, as we know it, will be good at mastering all of the AI work, such as coding. I don't know if that's a question more as a comment, but if you all have thoughts on like yes or
Certainly in every aspect, having someone who knows technology, understands, and can bring technology to bear on a problem is helpful. Right. And there are always those people that can provide that crossover, not to do both jobs, but to work together to accomplish the job in a better way.
And I've spoken in a lot of forums, panels regarding automated speech to text and transcribing, and there's been this fear of like, okay, are these jobs just disappearing then? Is there no longer going to be a transcriptionist? And my answer is usually no. You're always going to have someone that massages that data at the end of the day. And so us incorporating automated speech to text in our oral history process has meant that we didn't get rid of our students. Instead, our students are spending less time per interview to bring the interview transcript where we like it. And that means they're more efficient. It doesn't mean we're not employing them anymore. We're not paying them as much, whatnot. Their training might be a little different now, but we had a record year for employing students last year and a record year producing content because we have less man hours per recorded hour thanks to the help we're getting through AI.
You're here.
all right, James, I think you're up for the next one.
Oh, I don't know. I was going to wait and see what Stephen was going to say, because the question is, what AI tools are best for automatically creating a life history timeline by date or event from my interview subject? I'd like to ingest a transcript from my interview and extract important dates, events, and locations. And honestly, the one I was trying to think about how I would do this if someone said, okay, James, this is what we need to do. And honestly, I would go and I would get my transcript like from Whisper or whatever, and then I would process it through Google's NLP that they make available, as long as in limited small amounts for free, which you wouldn't pass the threshold likely, so and I would run it through that because it's going to pick up at least publicly known important locations and names and things like that. Now, if they're not in that, if it's just meant, oh, that person's birthday, well, it's not likely to pick that up. But I don't know, those were my musings on how to try and solve that problem.
So as I said before, I haven't gotten into this yet, so I don't have an answer for you, but I do know of at least one of our panels during the symposium, there is someone working on this with a specific GPT. And that would probably be a good panel to attend and hear about their progress. So sorry about that teaser, but I do work for them.
No, it's true. This one I can handle. So the question is, I guess the general question would be, what is the advantage of going through GitHub? For someone like me, that seems way more complicated. It depends. One, you can go to the GitHub page and you can actually read and see, is this something I can do or not do? Do they give an easy way? Or is it really complicated and no, I'm going to need some help on this? That's the first determination to make, right? And you can do that because GitHub exists. If it weren't for GitHub, you couldn't do that, and you would just have to buy a solution from someone. That said, you can look and you can see on both GitHub, and then you can search and see if there's a way, like for FFmpeg, for instance, which was one of the projects that is used by Whisper. You can search and find sometimes graphical front ends for FFmpeg. In fact, you can find 60 or 100 of them because it's so powerful. There's always someone trying to figure out some way to make those options available in a graphical user interface. That said, so many of them only work graphically for that one solution. They don't work across a lot of different solutions, and so may or may not be of utility, right? It just depends on what problem you're trying to solve. But the first step really is to check it out on GitHub. Go from there.
Yeah, and it's kind of your environment. and your own background. Not everyone attending this webinar today either has the background or wants to obtain that background to be able to install their own Python script on their own computers to run a lot of these things. But as James said, I think one of his great examples was like, this is the GitHub page, and then here's a Colab example of this particular. And that's the sandbox where someone has set this up so that you don't have to do that yourself. You can go to that and see what this is all about, which is great, which is, again, the helpfulness of most people in this community doing things like that for each other.
All right, we have one more question left in the Q&A, and we are just past time, but I think we can go ahead and finish it up. So do you know of any?
That's for Stephen. It says Stephen on there. So this is for Stephen.
Okay.
Go ahead.
Any products that can be used to compile passages from many oral histories in your archive on a particular topic. It seems that goes beyond indexing. Okay. So on the one hand, I'll say this is the joy of the transcript. And depending on the transcripts that you have, that you could do word searches in and upload that metadata, that is the transcript, the words from your transcript, and do full searches throughout each of those interviews. Some of that is done through digital asset management systems. So for example, my collection has over 4,500 interviews. You can search online right now. You can search any word, any phrase, anything, and get the hits, and then go through those hits and see how accurate that is to what you're interested in. That's a very low bar right there. But if you're applying artificial intelligence on top of that and you're looking to do a little something more, then there's different ways that you can go at that. I mentioned NVivo earlier today. That's just that textual analysis that you can feed it an entire project's worth of transcripts and do analysis and find specific phrases, specific topics that these 12 interviews and rather than these 3 over here share stories about this particular thing. And then I'll do one more plug. A couple of years ago, Baylor actually released an open source version of NVivo called Butane. It has a lot of the same skills involved, and that runs in a Google Colab environment. So, so maybe check that out too. But there's a couple different ways you can get to that, and I think especially as AI gets more into this summarization indexing world, we're going to see more and more of that pop up.
Definitely butane is the closest thing that I know of. Try and do that. It's hard to find a tool that will do that across so many different interviews.
And hopefully it's a good entry point too. You can even generate a full-throated little report of all sorts of different analytics, even if you don't know exactly what you're looking for. All right.
We made it through the first round of what is this thing we're talking about. So
yeah, great. Thank you. Thank you everyone for attending. Thank you, Sarah, for moderating our Q&A. Thank you so much to my co-presenter, James Fowler. I learn something from him every time I interact with him. So
likewise, it's wonderful.
We're very happy that everyone was able to come out to this webinar. Hopefully you learned something. Hopefully we didn't confuse you more. But regardless, come to our symposium in 2 weeks and check that out. Remember, it's oralhistory.org/AI if you haven't registered. And the recording of this webinar plus the transcript will be available, I'm hoping, tomorrow on that page. So until then, we'll say farewell.
Yeah, thank you.